Hi, my name is Kent Lee and I teach computer science at Luther College. Let's say that we wanted to write a program to help our little sister or brother learn how to do subtraction. To do something like this, we would like to be able to generate some random numbers, and random numbers, it turns out, can be generated easily in Python if we import a module. This is something we frequently do in Python. We frequently want to get code that somebody else has written and use it in our programs. And if we're going to import the random number generator in Python, we start out by writing import, the word import, and then the package that we want to import. Now you need to know what package it is you want to import. In this case, I'm telling you that we want to import the random package. This random package has a random number generator in it, and we can test it out here real easily if we say x is equal to random. So to use this package, we type the name of the package, random, and then we type the name of a function that we want to call within that package. In this case, the function's name happens to be random too. So we type package name, that's what comes first here, that matches this package name, and then function name. And in this case, our function is called random. I'm just going to go ahead and call that, and then I'm going to print x just to see what happens here when I go ahead and run that. And you can see here I get a random number generated. That random number happens to always be between 0 and 1. And it's a float, as we can see, and every time I run it, it appears I get a different float. So this is a random number generator that I have here. Now, if we're going to teach our younger sister or brother to do subtraction, I guess we have to decide at what level they're at. And I'm going to assume they're at a level where they are adding and subtracting four-digit numbers, let's say between 0 and 100 with 2 decimal places. So if that's the case, let's go ahead and modify our program so that given a random number like this, we go ahead and generate a random number from this that is between 0 and 100. Now to do that, what we would do is we would go ahead and multiply our first value, let's call it our x value, and that's going to be equal to x times 100. We'll multiply it times 100 so that we get, actually we're going to multiply it times 10,000 so that we get a number between 0 and 10,000. And then we're going to go ahead and round that number, or actually we'll just do an int of it. We'll do an int of that number so that we get a number now between 0 and 10,000 with no decimal point. And then we'll go ahead and divide it by 100.0 again so that we get a number between 0 and 100 with 2 decimal points. So if I go ahead and print xval at this point, and you notice I'm using a technique here of writing things incrementally so I can kind of see what's happening as I go along. And you can see here I'm getting numbers between 1 or 0 and 100 with 2 decimal points maximum. So and we're getting lots of different numbers here as we go. We could do that again for y. I'm just going to go ahead and copy this code and paste it in again. And then we'll go ahead and change it so that we get a value for y as well. Y and y here. And then we could go ahead and print our y value if we wanted to. I actually don't think we need to print anymore. I'm going to throw those 2 lines out. So now we have an x value and a y value, and we want to ask our younger brother or sister what's the difference between those two. So we'll go ahead and ask for input, and we'll call it our answer, and we'll say answer is equal to, and let's convert it to a float because the answer will likely be a float, input, and we'll say what is the value and then we'll go ahead and we're going to put this in our input string. So in our input string, we cannot separate things by commas, but we can put pluses in between things to concatenate strings together. So we're going to say, what is the value of, and then we're going to have to convert our x value to a string. What is the value of our x val? And then we're going to do a plus, and then we're going to say minus, the minus sign there, so that that prints, and then string of our y value. And then we'll do another plus, and then we'll do equal to. And that should be our prompt then at this point for our answer. And now we would like to go ahead and compute the real answer. Okay, and see that the real answer is x val minus y val minus y val. And we'd like to go ahead and ask now, did our younger sister or brother get the answer right? So let's go ahead and give this a try and see if their answer is equal to the real answer. And we're going to go ahead and print, you did it. And else we're going to go ahead and print, no, the answer was. And if this is in a print statement, we can go ahead and put a comma between things. So in this case, we're going to use a comma. Real answer. Okay, so let's go ahead and give this program a run and see what we end up with. What is the value of 60.34 minus 28.58 equal to? And I should end up with 31.76. So let's give that a shot. 31.76. And it tells me no, the answer was 31.76, and you can see all the zeros and a 5 there. So once again, we're dealing with round off here in our program, and having to make our program work in spite of the fact that floating point numbers are approximations of real numbers. So we really have found here that this is probably not the way to see that those two things are equal. And in fact, you never want to compare floating point numbers for equality just for this reason, because round off error can make them very close to equal but not quite. So here's the way to fix this. Instead of comparing floating point numbers for equality, what we would do is we would subtract one from the other. Now, subtracting one from the other may result in either a positive or a negative value, so we're going to do the absolute value of that, and ABS gives us the absolute value. So now what we're looking to see is this very close to 0 or not. But being close to 0 is relative to how big the numbers are. So what I'm really going to do in this case is I'm going to take that value and I'm going to divide it by I'm going to actually put this whole thing in the absolute value. And I'm going to divide that by my real answer in this case. And I want to see, is that percentage very, very small? Is that less than? In this case, since we're going to the nearest hundredth, let's see if it's within a thousandth or not. So I want to see, is that less than, that percentage that I have here, is that less than 0.01? I guess that would be within a hundredth anyway of the answer, and that ought to be pretty close. We could even go within a thousandth, and I'm sure that's going to work in this case as well. So here I have transformed this asking if real answer is equal to answer into subtracting the two values, dividing that amount by real answer in this case, which gives us a percentage, which may or may not be positive. If we do the absolute value, we're guaranteed that the whole thing is a positive value, and then we're going to check to see is that less than some percentage of the difference from the actual value that I was looking for. So this is how we ought to go ahead and compare floating point numbers. Let's give this a try again and see what we end up with. So if I do 98.51, let's see, that would probably be, I think I can figure this one out, that would be 92.98, I believe, if I am computing it right here, and in this time I did it. So I found out what the answer was. So I'm within a thousandth of the right value in this case. So when you're comparing floats, what you want to do is subtract the two floats, divide by one or the other value. In this case, it makes more sense to divide by the real answer to find out whether I'm within some percentage of the correct answer here. And absolute value is certainly necessary to make sure that the result of the subtraction is going to always be positive, so that I can compare with a percentage that is greater than 0. Hopefully that will help you at some point. And again, real numbers are infinite, floating point numbers are finite, and that's why we have to deal with this, because a finite number of floating point numbers are approximations for the infinite number of real numbers that we have to deal with.